Hi everyone, this is Miss Scott. Today we're going to cover section 2.5 in this video, reason using properties from algebra. We're going to answer this question here: how do you solve an equation and explain the steps? This is one of my favorite lessons to teach because it is really straightforward. There's not a lot of confusion with this, and this is all stuff that you should be really comfortable with if you have taken an Algebra 1 course. So, first of all, we need to talk about what an equation is. And an equation has to contain an equal sign. So, on the other hand, we discussed this back in chapter 1, expressions have no equal sign. So when we talk about solving equations, you can't solve an expression because it doesn't have an equal. You can only solve things that have an equal sign. All right, well, to solve equations, we use these algebraic properties of equality, and there's one for each operation. There's one for addition, subtraction, multiplication, division, and then substitution. So the addition property tells us that if A equals B, then A plus C equals B plus C. So you can add something to both sides. Likewise, you can subtract something from both sides. You can multiply both sides of an equation by something. And you can divide both sides of an equation by something. So typically when we use these properties, we're using numbers here, so don't let all of these A, B's, and C's confuse you. You know how to use these properties. So the last property is a little bit different, but that's the substitution property, which tells us that if A equals B, then A can be substituted for B in any equation or expression. Whoops, substituted. All right. And we did some substitution back in chapter 1. All right. Let's look at a few more properties. These are probably familiar. At least the distributive property probably is. That tells us if you have A in front of this quantity B plus C, you can take that A value and distribute it and say A times B plus A times C. So you can multiply both of those by the number in front. The next three properties are probably new, or just not as familiar, but the reflexive property is really straightforward. It just tells you that A equals A. Something equals itself. The symmetric property tells you that if A equals B, then B equals A. I think of it as like symmetry, like a mirror image. The transitive property is a super useful one. We're going to use this one a lot. So it starts with this. If A equals B and B equals C, then what you can do, since they both are equal to B, you can, what I call, cut out the middleman and just say that A equals C. All right, so this property here is going to be really useful for us throughout this geometry course. Okay, so now we're going to use some naming of those properties. Example 1, we have if 3x plus 2 equals 17, and 17 equals 3x plus 2. So it looks like all they did was flip-flop the order. The flip-flop the order property is the symmetric property. Okay. Example 2, if x is a real number, then 5x equals 5x. If you don't change anything in the problem, something equals itself, that is the reflexive property. So when you don't change anything. All right, example 3, if 3x equals 2x plus 2, and 2x plus 2 equals x plus 4, then 3x equals x plus 4. So if you look at this, 2x plus 2 and 2x plus 2 is shared. And then what they're saying is the first and last have to be equal to each other then. Remember, that's that transitive property. So it's when you cut out the middleman. All right, number 4. Given that segment AB is congruent to segment CD, and segment CD is congruent to segment EF, segment AB is congruent to segment EF. Again, this is shared. They're cutting out the middleman. So this is not the reflexive property. What am I thinking? That's the transitive property again. And you can use the transitive property for numbers, for equations, for segments. That's why it's so useful in geometry. Okay. All right, let's do a little practice of solving equations and then naming the property used for each step. So this is kind of the basic proof writing stuff that we're going to do quite a bit in this chapter. We're going to solve an equation and prove why we can solve it. So in number 5, we have x plus 5 divided by 3 equals -4. I don't like to have fractions, so I like to multiply to get rid of those. So let's multiply both sides by 3 so that these 3's will cancel. And we end up with x plus 5 equals -12. Well, we can do that with that multiplication property of equality. So I'm going to abbreviate that a little bit. All right, so now we're left with x plus 5 equals -12. Well, we're trying to get x by itself, so we have to subtract 5 from both sides. So these will cancel. We end up with x equals -17. Well, why can we subtract 5 from both sides? Step 2, we use the subtraction property of equality. Okay. All right, so let's look at another example. If you'd like to try example 6 on your own, that would be just fine, and then you can watch the video, see how you did. All right, let's take care of this -4 first. I'm going to distribute that into the equation, so I end up with -44x plus -8 equals 80. And I'm actually going to change this. If you add a negative, that's the same as subtracting. So let's just change that to -8. And we are able to do that with that distributive property up above. Okay. So from here, what should we do next? Let's add that 8 to both sides. So these 8's cancel. We end up with -44x equals 88. And why can we do that? Well, we can do that with the addition property of equality. All right. Next, to get x by itself, our very last step is to divide both sides by -44 to get these guys to cancel. And we end up with x equals -2. So that third and final step was the division property of equality. All right, so pretty straightforward there. You know how to solve equations. If you're not comfortable with it, let me know. I can give you some helpful tips for that. All right, let's go ahead to that very last example. In the diagram, AB equals CD. And if you notice, they have those tick marks on there to show that. Then we're going to show that AC is equal to BD. Which property allows you to make this conclusion? Well, do you notice that AC is the combination of this segment AB and segment BC? And likewise, segment BD is the combination of BC and CD. So let's start with the fact that we know AB is equal to CD. And then what I'm going to do is they both share this segment here, BC. So let's add that segment BC to both sides. And when we do that, we end up with AB plus BC equals CD plus BC. So we added BC to both sides. All right. Well, AB plus BC is what segment? It starts at A and ends at C. So what we can end with here is that AC is equal to, and then CD plus BC is simply this whole segment here, which is BD. All right, so that's why we can make that conclusion. What did we do in that very first step right here? What property allowed us to do that? Well, that's the addition property of equality. So these properties are going to be really helpful when we get into proof writing. Okay.